Let's try and run the full-size Deepseek R1 model locally on cheap consumer hardware. I'm going to start by getting this 2 terabyte SSD and installing it into my computer. And the whole trick to this whole adventure is we're going to assign half of this hard drive to act as hard drive, and we're going to assign half of this hard drive to act as swap, which is basically using your hard drive as extremely slow extra RAM. So this desktop only has two 8 gig RAM sticks. It's got a simple Ryzen 7. It's got no graphics card. But this 2 terabyte SSD is going to pretend to be a terabyte of RAM, and that's going to allow us to extremely slowly run this model. I go ahead and boot a live Ubuntu 24 USB stick. This USB stick is going to let us install Ubuntu on this computer. That Ubuntu install is going to let us run the model. Once Ubuntu started booting well, we'll go ahead and start this. We're going to sail through the install process using basically all the defaults until we get to the point where it asks about partitions. We're going to go ahead and manually partition this. We're going to set the first roughly 900 gigabytes as just your normal Linux mount. And then next, we're going to take the remaining 1.1 terabytes and we are going to assign it to be swap, which is our simulated RAM, which is going to let us hold this massive model. Once we've done that, we can just let it finish installing and then boot it up. Once we're booted up, we can go to ollama.com, which is this model running software. It has some install instructions. We just get this curl command, copy it. We can hit Control-Alt-T to open up a terminal and paste that command into the terminal. Now it'll probably say curl's not installed, so we'll probably have to do some form of sudo apt install curl. But once that finishes, we'll have curl installed. And then after that, we can go back around, run the original Ollama install command, and then wait as Ollama goes and downloads its stuff and installs. After that, we can go back to the Ollama website, go to Deepseek R1, and it'll list a bunch of different sizes of Deepseek. Now, if you just want to have fun, go ahead and get the 7B, which is a lot smaller, but to run the full size, go get that top command saying getting the full size model. Paste it into the terminal, hit enter. First time it refused for some reason, go ahead and just run it again, and second time's the charm. It just starts downloading the model. Now this is 400 gigs, so we're just going to have to wait overnight as this thing downloads this massive model. When I come back in the morning, amazingly enough, it's just sitting there ready. So I guess I go ahead, get the monitor open, type in my prompt and hit enter, and then very predictably, it's extremely slow. So let's look at the monitor to see what's happening. RAM usage is slowly but surely going up, and eventually we use up the full 16 gigabytes. And at that point, the computer just starts using swap as if it's RAM. So at this point, it's just filling up the SSD with Deepseek model in order to sort of simulate RAM extremely slowly. And over the next about 15 minutes, this model is going to successfully load into RAM. You can see on the bottom the hard drive is working overtime. I've sped it up. We can see that it's just absolutely wailing on the SSD. The swap usage, the green line on the second graph, is slowly but surely sailing all the way up to about 450 gigabytes of RAM usage or swap usage. And just like that, we get our first token in the terminal. The first token looks like a think token. If we wait another roughly 50 seconds, 1 minute, we'll get our next token. So I've sped up the rest of this, but this is beautiful. We are actually getting, at about 1 token per minute, the full power Deepseek R1 response. This is the full size model running on a cheap computer with only 16 gigabytes of RAM and no graphics card. We're doing it all by running this poor SSD into the ground. Now, one thing that's kind of interesting to consider is over the course of creating this response, we do about 5 or 6 terabytes of writing to this SSD. And this SSD is actually only good for about 1,200 terabytes of write total. So this response actually used up about 0.5% of this SSD's entire lifespan. I got this SSD for about 120 bucks, which means we're using of the order of 50 or 60 cents of SSD wear to get this single response. So I don't recommend this method to actually produce a lot of useful output. You can probably rent server space somewhere for cheaper than the degradation of the SSD. But just in a conceptual, beautiful, incredibly cool sense, we're able to run the full-size Deepseek model locally on really inexpensive hardware, and that's beautiful.